Good evening. So I'm going to talk about converged infrastructures, and a lot of you may not have heard these terms before. So getting started on the first chart here, I want to get at least an initial description of where the market is going, right? And what's the difference between these infrastructure systems. So you have the traditional systems in the data center where you have islands of compute, networking, and storage, and you deploy solutions on top of that, right? The market is going in a different direction now. So in order to make it these things easier to manage, they get integrated into rack systems where you can find all the aspects of these solutions like storage and compute and networking and the managing aspect, and the solutions themselves, they are deployed within these rack systems, right? So this is what we call converged systems. And then there is another term where the industry is going on a direction that is even more integrated nowadays. So they call it hyperconverged. And there are discussions on the industry what that exactly means, but there are, at least in some aspects, everybody is in agreement. So going to hyperconverged, you have more software-defined solutions, right? So you have commoditized hardware where you have all your resource aspects represented there, and you use technologies like OVS for virtualizing the network aspects. You use distributed storage systems like Ceph and Swift, right, to virtualize your data aspect of the systems as well. One other thing I wanted to just point out here is that the market is going in this direction today. So the market as a whole, it's like more than $400 billion market if you look at integrated systems as a whole. But you can see that the traditional systems are decreasing in terms of yearly deployments, right? So right now, the converged system deployments, they're growing at a compound annual growth rate of more than 10%. And if you look at hyperconverged systems, they're growing even more, like they're growing up to 60% year to year, right? And there's a $19 billion market opportunity on these types of solutions. Usually they are delivered in two models. They're what they call single-SKU systems. And what that means is that the provider sells the whole package solution as a whole. So it sells you a rack. It has storage and compute and networking, and it has support, and it has documentation and the management software embedded into it. And then there's reference architectures. So reference architecture is they provide you with a bill of materials, and you build your own system, right? So they provide you a reference architecture for both the hardware and the software aspects of the solution. And that includes software that you can download or you can purchase. It depends. And most of these systems are going more towards the open direction today. So that's why it plays a big role into OpenPOWER with open hardware, open architecture of references, like supporting OpenPOWER. And it plays a big aspect of open source software as well for the management aspect. So the key message here is that Power and OpenPOWER, they have to play a big role in this market. That's the market where things are growing nowadays, and if we don't position Power and OpenPOWER ecosystem hardware in these markets, we're going to be left behind, right? This is this chart is just for information. Last year in IBM we worked on a converged system. We call it Pure Power. So it is one of those single SKU solutions. So you have a rack where you have three kinds of networks. So we have a data network, we have a management network, and you have a fiber channel network. And you have all the aspects sold inside the same rack, right? So we have V7000 to support storage, and you can virtualize the storage in the V7000. You have the Power 8 nodes to fulfill your compute aspects, and you have the management nodes as well. We use the x86 for this solution to manage power. So we were talking about managing to power here, not running to power, right? And this is one other aspect that it's really under addressed nowadays. And then on the right side, it's just the management stack. So we have the physical infrastructure, we have the firmware that's assigned to each of these devices. And what we really, our team contributed really was on the higher layer where you have the integrated management part. So, and I'm going to get more into this, but that was one of the aspects where we started to integrate open source software to provide management functions like monitoring and provisioning and other kinds of management functions, right? And we saw that there was a kind of a lack of support for managing to power. Right now, nowadays, we worry a lot about our solutions and everything compiling and running on power, but this aspect of managing to power, it's a little bit under-addressed right now. So what's next after this Pure Power solution, right? So we would like to move to hyperconverged, and then moving to hyperconverged solution, we need to use commodity hardware. We have to be lower cost. That's one of the reasons why we want to go open with OpenPOWER ecosystem to be built on these racks, right? And we would like to use open software as well for the management aspect. So if you look at keywords like KVM for the virtualization layer instead of a Power VM, like the legacy technology that we had at IBM, right, for virtualizing power. So we want to move to KVM, which is open, and it's more used in the open community right now. So we want to use OpenStack instead of a virtualization product like PowerVC, for example. We want to use the community-supported OpenStack. We want to use containers, right? So we want to support Docker and Kubernetes, and we want to support the storage technologies like Ceph and Swift, and virtualize networking with VXLAN and OVS as well. So these are all the kind of hot buzzwords nowadays for these kind of integrated solutions. And the other hot buzzword is how you deploy and how you operate these solutions, right? So the traditional way that you would do this is you develop and you release your management software, and then you install it, and then you operate it, right? So nowadays they have the solutions being deployed in what they call DevOps. So it's like just a continuous integration and delivery of the solutions. So it means that you deliver your management applications and your infrastructure itself. You monitor them, and you retrofeed the performance analysis and many other aspects of management. You retrofeed back to your to tweaking your infrastructure, and you are in a continuous cycle of enhancing, tweaking, and delivering it, right? So when we're putting this together, and even before when we released the Pure Power solution, one aspect that I mentioned before was that we did see little support to manage tube power, right? So if you, there are many layers of management that you can have in these solutions. So you can manage the solution as a whole, you can manage the services of the solution, you can manage the operating systems on the hosts, you can manage the virtualized guests, you can manage the firmware, and can manage the hardware capabilities associated with the hardware, right? Like, for example, here that we're hearing a lot of buzzwords about optimization using CAPI and CUDA. So you need to understand that in a data center you have a mixed environment, right? So you need to know which nodes you have these capabilities and how to really deploy to these nodes correctly using workflow and orchestration applications today. And if you look at these applications in the DevOps environment, they don't really have off-the-shelf support to know what kind of hardware I have, especially on the power world, right? So they don't know how to do that. So that's one of the biggest issues right now. And one thing that we want to do is having conversations through the OpenPOWER Foundation and try to have a kind of a work group, an incubation work group, try to promote more of this managed tool aspect to support power in the existing solutions out there, right? So, and this is how we want to do this. So on the right side, you see the kind of the DevOps and continuous integration architecture on how you deploy these solutions. But we can't do that alone. So we need to pick kind of one of the capabilities, and then you have to look at the market. There are thousands of applications out there. If you look at one aspect like health monitoring, you're going to see just in the open source world, for example, you want to see dozens of applications that do the same thing, right? So we can't instrument all of them at once to support OpenPOWER, or can we, right? So one of the intents of this discussion is to try to make to have a single point of reference for these two providers, so they know how to manage the OpenPOWER aspects. So do libraries to make it easier for them to understand when a given hardware supports CUDA or GPU acceleration or supports OCC for power cap management, like another speaker mentioned earlier today. So that there are many these aspects that we can provide as a library and make it easier for these two providers to build plugins to support power off the shelf, right? So if you live in a data center, for example, it's really very likely that you heard of tools like Nagios or Sensu or Isinga or Zabbix. So the intent of this this kind of incubation work group that we're proposing is to make it easier for these tools to support this off the shelf, right? So support managed power. So that's one of the reasons why we're kind of showing this this work. We're starting to do some work in IBM, but we want to be open, have an open source kind of an open source initiative where we would like to engage with other partners as well to help us to define what are the reference architectures that we want to see in these solutions, what are the most popular tools that we want to instrument, and help us define what are the libraries that these tools need to use, right? And this is a big picture of what such thing will look like. So you see on the bottom the reference architecture based on OpenPOWER. You have compute nodes with large CPU capabilities and maybe GPU capabilities as well. You have other power nodes where you have a large number of hard disks, right? So, and I suppose it doesn't have to be only one reference architecture. It could be multiple ones, right? Then there is the infrastructure as a service aspect. And a lot of people today, they use OpenStack. And OpenStack already supports Power on a certain degree. But OpenStack alone will not provide everything that you need to manage these solutions on a data center, right? So like I said, there are thousands of other applications that run alongside OpenStack or to complement OpenStack. So then that's where it enters this green layer. That's where we're working on right now. So well, what we're proposing is to have this extensibility framework where we would have these libraries and capabilities defined. Then we would make them available to the tools on the upper layer. And then I just put some examples of some tools there. And tries to cover multiple aspects of DevOps, right? So DevOps, even from the beginning, from source code and having repositories like Git and having automation builds with Jenkins, for example. Then all the way to the provisioning aspects. There's very popular tools today. Red Hat bought Ansible, for example. Ansible is a declarative provisioning tool. Then you have your procedural provisioning tools like Chef, and then there's the solutions from Canonical as well, Maaz and Juju. So what I'm trying to say is that every way you could it, every aspect you look at in there, like provisioning or configuration or discovery or inventory, you're going to find multiple applications, and they do make sense. They do influence how people choose to purchase their infrastructure today. So you can see a lot of people that will look at when they're expanding their data center, they're going to look into see if they already support the tools that they are familiar with, right? So that's one of the reasons why we want to provide these capabilities and make it easier for these tools to manage the power. Okay, so and this is just the final chart. So like I said before, this is an initiative that is being discussed. There is a work group in the OpenPOWER Foundation. It's called the Integrated Solutions Work Group. And this layer, this incubation layer, support other tools, not only OpenStack, but other tools like the ones that I mentioned before. So we're discussing how to better organize and how to better engage with partners in order to help us build this ecosystem, right? So if you're interested, if you are a tool provider or if you're a hardware provider that you like to see these popular tools support your hardware, we're looking for your help, right? So just contact this work group in the OpenPOWER Foundation or just contact myself. My email is at the bottom there. So we're trying to put this together in the next 2 to 3 months or so, and try to reuse things as much as possible. So there are assets already, like I mentioned before, in OpenStack that supports Power. There's this Super Vessel Cloud that a lot of people here heard about. They also support a lot of the same kind of functionality that we would like to streamline, right? And there is So there are other open source projects out there. If you look at provisioning aspect, for example, we're going to see a project called Ursula that uses Ansible to deploy OpenStack generically, and they are adding support to Power right now, right? So we would like to reuse as much as possible, and then kind of add more value on the pieces that are missing out there, right? So that's what I had. So, thank you.